All right. Well, we know things are getting bad when we're starting to pray to God, right? All right. All right. So, hold on. Let's see. I feel like you guys need a break. Am I right or wrong? You can always put Jesus as the answer, but I don't think Alex will take it. Okay. So, break time, yes or no? Yes, okay. 15 minutes? Come back at 11:30? Who asked me to talk to me after class? I can't remember who it was. It was you. Can you do it right now? Because after class, I kind of have to run. I've got tutoring at 1:30. Is now okay for you, Damien, or do you need a break and you don't want to talk? Yeah, it's 954-383-3163. I'll go find my phone. I'm going to turn my speaker off. I'll see you in 15 minutes. Okay, I'm here. Give me one sec. All right. Is everybody back? I guess if you answer yes, then you are. Okay, it says graph the polar equation. R equals 4. What does the polar equation R equals 4 look like? Anybody have any ideas? No? Well, I'm going to say, nope, we're not there yet, Luis. We're getting there, but we're not there yet. Well, something with a radius of 4, my guess looks like a circle with radius 4. Right? Does that make sense? Hello? Can you hear me? Okay. And theta equals pi over 4. Michael W. Any ideas? Okay, I'm just looking to see. So we said R equals 4 would look like a circle, right? With radius of 4. So what would theta equals pi over 4 look like? You may not know. It's just I was just asking. I haven't taught this yet. No, would it look like that? Does anybody have any ideas? It does. It looks like a line. So what does this graph look like? It looks like a line where this is pi over 4. Right? Does that make sense? Because any point along this line is a point at theta equals pi over 4. I didn't ask anything. I just said I'm just asking about B. It does go in both directions because remember, if I gave you a point -2, comma pi over 4, it would be in the opposite direction, right? Does that make sense to everybody? Okay. Okay, good. Anybody not understand? Okay. We will not be graphing things like this in this course. I just put this in here so you could kind of see that depending on what the equations are that we're being given, that you can have graphs that look like different things. These are called roses. There's words like cartoid and lemniscate and all kinds of things. Maybe some of you did this in high school. I'm not really sure. But they look like these are actual graphs. We won't be doing this. Yes, actually, chemical orbitals do look like these do model that. Yes. I'm not a chemistry person. That's about the best I have, though. All right, so now we want to convert from rectangular to, well, we already did this, sorry. No, we want to change, transform an equation from an equation. This is different. The last time we did points, now we have transforming an equation from polar to rectangular. Okay? Hold on one second. I have, it's supposed to be the touch is supposed to be off. Hold on. Touch. Oh, it says it's off. Why am I? It's weird. My thing says my touch thing is off, but it seems to be working. Let me see. I'll turn it off again. Okay, now it's off. Okay. So how do we transform from rectangular to polar? Well, we have some equations, right? We know x squared plus y squared equals r squared. We know that x equals r cosine theta. And we know that y equals r sine theta. Right? We know all that. So I want to know, I have r equals 4 sine theta. And I know when I'm done, instead of having r's and thetas, I'll have x's and y's. Okay? So I'm not going to call on anybody because I haven't taught you anything. So does anybody want to give it a shot or have any ideas about how we can do this? Okay, well, yeah, Rowan. Okay, not you. Okay. Well, I'll do the first one. So I have, if I'm looking at what I have, I would say that I don't have enough to make any of these things happen. But what if I multiply both sides by r? Then I'll have r squared is equal to 4r sine theta, right? So now do I have anything that would help me? Richard, do you want to give it a shot? Do you have any ideas?
Sure.
I want to make sure I change everything to x's and y's. Right now I have r's and thetas.
So we'll first use the r cosine theta to find x.
Sure. So well, we don't have r cosine theta. We have what?
Oh, you're right. We have r cosine theta.
Right. So what can we say that equals? Don't complicate this. This is pretty simple at this point. Try to look for the easy solution, not the hard one.
R divided by 4? R over 4?
No, I don't want any r's left. I know that r sine theta equals y, right?
Right.
So I can say this is just 4y.
Oh, okay. Right.
See what I'm saying?
Yeah, I see what you're saying.
Okay, good. Does everybody kind of see what I'm saying now? Because now I have one of my r's turned to x's and y's, but I still have an r squared here. Do you know how to finish this off, Richard, or do you want me to ask somebody else?
I'm not 100% sure. I could guess, but
yeah, just give it a shot. It has to do with exactly what's up at the top here.
So r squared equals x squared plus y squared, so it'll be x squared plus y squared equals 4y.
X squared plus y squared equals 4y, right?
Yes.
Do I have any r's or thetas left?
No.
I just have x's and y's, right?
Right.
I'm done.
That's it?
Yeah, it's converted from polar. This is polar. All there is r's and thetas, right? Polar has r comma theta. Rectangular has x comma y. So when I get rid of my r's and thetas, then it becomes x's and y's. I'm done. Okay?
Okay.
See, I told you, don't overcomplicate it. These do get a little bit more complicated, but not really much. It's all really just this. Let's see if we have another one. Okay, so we have transform the equation 3x squared plus 3y squared equals 2x from rectangular to polar. Now we're going from rectangular to polar. So, Stefan, how would I go from rectangular to polar? Are you there, Stefan? Your mic's not working. Are you on a laptop? Because if you're on a laptop, you should have a mic. Can you hear me, Stefan? Okay, I'll continue. Iman. You here? I know you have a mic.
Yes, I do. Yes.
There we go. Oh, so much easier when you have a mic. Okay, so transform the equation. Do you have any ideas? We're going to use this.
To be honest, I have no idea.
Okay, well, let's
start
do
it.
with it. What?
I don't know how to start it.
Well, we want it. It says from rectangular to polar. So we're starting with x comma y, and we want to go to r comma theta. Okay?
Okay.
Do you have any, like, if you're given, you have to use what's down here at the bottom.
Okay.
Can you see anything you can do? Any one thing that would get rid of an X or a Y? No?
I need a hint.
Give you a hint. I gave you about as many hints as I mean, the answer is going to be using the things here at the bottom, and I have X's and Y's here, so I need to get rid of at least an X or a Y somehow. I'm trying to think of any other hints I can give you. You don't see any way to get rid of one X value. And I'm not saying that in like, oh, you're stupid. I'm just saying I'm trying to figure out, like, how to lead you there, because I don't know. You don't see anything?
Can we put the 2x to 2r cosine theta?
Perfect. So I have now 3x squared plus 3y squared is equal to 2r cosine theta, right?
Mm-hmm.
Okay, good. See? You got one of them out. You see anything else happening here that would maybe help us?
Can we put like the 3
Just say it. If you say it, if it's wrong, it's okay. Just just say whatever you're thinking.
Okay. Can we substitute the x squared to y r squared minus y squared?
R squared minus. So you want to change x squared to r squared minus y squared? I mean, is that what you're saying?
Yeah.
You could do that. Yes, it will still work. Let me give you a helpful hint, because that will work, by the way. I'm just going to give you a much more direct way. Does that help any?
And then we can substitute the x squared plus y squared to r squared.
Perfect. So this is 3r squared equals 2r cosine theta, right?
Mm-hmm.
And then let's simplify. This works, and then we can simplify, right? We can do what? How can we simplify this? By not 3. That wouldn't actually simplify anything. I can divide both sides by r. Yeah. How come I can divide both sides by r when I always tell you not to ever divide by a variable? Why do you not ever divide by a variable? Does anybody know? Anybody know why you should never divide by a variable? Oh, okay. Nobody knows? Well, what if that variable equals 0? So if I have 3x squared equals x, and I divide both sides by x, Actually, let me just say, do I want to do that? Sure. Then I have 3x equals 1. So I get x equals 1/3, right? But isn't there also one part here where x equals 0 would be an answer? And that's actually not the one I wanted. Let me give you a better one. So first of all, I just lost one of my solutions by doing that. But what if I have 2x equals x, right? And I divide both sides by x. I get 2 equals 1, right? Well, that's not true, right? That happened because really what happened is if I solved it properly, I would subtract x from both sides, and then this would be x equals 0, because the solution to that problem is x equals 0. So when I divide by a variable, if that variable is 0, I get lots of very strange results. Okay? So the correct way is to have the square root of, no. So the question I'm asking is, why can I? Because I can divide by r here. But the question is why? Don't take the square root of both sides. If you take the square root, so okay, thank you for saying that. So if my answer is basically a circle, and I take the square root of both sides, what happens is I eliminate the top half. Yes, exactly. I would only have the top half or the bottom half of my circle if I took the square root. So don't take the square root. The reason we can divide both sides by r is the radius, and it won't be 0. Exactly. If it's 0, we don't actually have a circle anymore. We don't have anything. We have nothing, right? So, so I can say the final answer is 3r equals 2 cosine theta. Exactly, because r is not equal to 0. Everybody with me? So in general, never divide by a variable, but here, since we know what r is, we know r is the radius of a circle, and that is not going to be 0. We can divide by r. Okay? Good? Would you some? Yeah. No. Well, you could. You don't have to. Just divide both sides by r. That answer that you have there is fine, Anka. Either way is fine. That would be correct as well. Either one. I just don't believe if you type into Alex 3r squared equals 2r cosine theta, they might actually ask you to simplify, or it might be wrong. I'm not really sure. Okay? And here's some more graphs drawn by a graphing calculator. I just threw that in there just so you can see what kind of shapes you can get from polar coordinates. All right, so that is the end of polar coordinates.